Hello, algebra. Here's your now for today. We're identifying least common multiples, 4 parts here. So for each of the parts, least common multiple, that means the smallest number that each of those numbers in the problem would multiply into. So for part A, 2 and 5, both of them would multiply into what other number? Okay, well, figure out the least common multiples for all of those problems. Hit pause till you got them, and I'll be waiting here until you get those done. All right, so let's see what the answers are. So part A, 2 and 5 both multiply into 10. For B, 3 and 9 both multiply into 9. It doesn't have to be a larger number. If one of the numbers works as the least common multiple for the other, go with that. For part C, 4 and 6 both go into 12. And a lot of people want to say 24 on that one, which is a common multiple, but not the least one. And for D, 8 and 12, those will both go into 24. I know sometimes people will say, hey, to find the common multiple, you just multiply the numbers together, which will always give you a common multiple, but 8 times 12 is 96. 96, that's not the smallest possible number that each would go into. So we're trying to get the smallest numbers because they're easier to work with. So elimination is the topic for today. We started this last time, and we're going to look at some slightly more challenging problems where we will need to multiply first, whatever that looks like. Our learning target for today, you'll be able to solve a system of equations using elimination by multiplying the equations first. So remember this checklist from last time, I hope, our elimination checklist. We've got to make sure all the terms are lined up in both the equations. Are the x and the y coefficients the same in both equations? Does either the x or the y, do they have the same coefficients? And decide, should we add or subtract in order to make elimination happen? Well, sometimes our checklist doesn't check out. Maybe the terms are not lined up in both equations. Then we can rearrange using algebra. Or sometimes the x and y coefficients are not the same in both equations. That is what we're going to look at today. What happens if the x and y coefficients are not the same? Well, if they're not the same, then we still need to make a decision. Are we going to eliminate the x or the y? Once we've identified which variable we want to work with, we're going to identify the least common multiple for that coefficient. I've abbreviated that LCM, same thing you saw in the do now. And then lastly, multiply one of the equations, or maybe you need to multiply both of the equations in order to get the least common multiple as the coefficient on whichever variable we chose. So if we're going with eliminating x, we want to make sure that in both equations, the new coefficient of x is that least common multiple. Here's what that would look like. We got a system, 2x plus 3y equals 5. That's my green. 6x plus 5y equals 19. That's my blue. So go through the checklist. Do the parts of the equations line up? Yes, x's, y's, equal sign numbers. Super. Do the coefficients of one of those variables, is it the same? For x's, 2 and 6. No. For y's, 3 and 5. No. Okay, so my coefficients are not the same. So I need to pick a variable to eliminate, x's or y's. Sometimes we don't know which one is going to work best. If we were to choose the x's, we would identify a least common multiple for 2 and 6. We don't need to worry about the x. We're just looking at the coefficients, so just the 2 and the 6. Least common multiple for 2 and 6 is 6, which means we need to change the green equation, but not the blue one. We can leave the blue. It already is 6. And just for comparison's sake, if we chose to eliminate the y's, we still need to find a least common multiple. For the y's, we're looking at 3 and 5. The least common multiple here is 15, which means I would need to change both the green equation to get it to be 15y, and I need to change the blue equation so that that coefficient is 15y. So my choices are either I work with the x and change one equation, Or if I'm working with the y coefficients, I have to change 2 equations. I would rather go with the easier one. I'm going to eliminate the x's because I only have to do half as much work. I only need to change 1 equation. Okay, so if we're going to eliminate the x's, my least common multiple is 6. I would like to have one equation have a coefficient of 6x and the other to have a coefficient of negative 6x, so that elimination will happen via addition, which is less confusing. So I'm going to leave the blue equation alone. It's already 6x. The green equation I will need to change. What do I need to multiply 2 by to get a coefficient of 6? And actually, I don't even want it to be 6. I'd rather it be negative 6 because, like I said, I want one equation to be positive 6x and the other to be negative 6x. Okay, well, I would need to multiply this top equation times negative 3. That will give me my x coefficient of negative 6. That's what I want. Okay, I'm going to rewrite both equations. So let's multiply that green equation. All of the numbers in that green equation I need to multiply by negative 3. Okay, so negative 6x. And the next term, I got 3y, positive 3y. That gets multiplied by negative 3 also. So it'll be negative 9y. The equal sign, you don't change equal signs. And then that 5 gets multiplied by negative 3. So that'll be negative 15. The blue equation, no changes. But I'm going to write it down again, so it's in the same place. So 6x plus 5y equals 19. Okay. My original checklist, decide whether I should add or subtract this, the last item on that checklist. So I'm going to add my x's. I got positive 6x in the blue. I got negative 6x in the green. If I add them together, the x's are going to eliminate. I kind of already said that earlier, but let's just clarify. I'm adding. So when I add straight down each column, 6x and negative 6x, those eliminate. The y's, I got negative 9y plus 5y. That's going to give me negative 4y. Equal signs, I don't actually add them together. It's just an equal sign. And negative 15 plus 19, that gives me 4, positive 4. Purple equation, that is my new equation. I've eliminated the x's, they're gone. Only thing left is a y. I can solve for y. I'll need to divide both sides by negative 4. Negative 4 divided by negative 4, that's going to cancel. Giving me 1y, or I'll just write down y, equals, and on the other side I had 4 also divided by negative 4. That's almost the same thing. 4 divided by negative 4 gives me negative 1. So there is my y coordinate. It's half of the solution. I've done most of the work, way more than half of the work, but I've only got half of the answer to show for it. So I'm going to take that negative 1, that's y. I'm going to put it back into any of the original equations and substitute it so I can find x. So I could use, just for clarification, I can use this blue equation. I never changed it, so I could use the original blue equation. I could use my modified green equation or the original green equation. I'm going to get the same answer no matter what. Which one should I choose? I'm going to go with the original green equation simply because there are no negatives and it's got the smallest possible numbers out of all those options. I think that's going to be easier. So I'm just going to write this down here. So 2x plus 3y equals 5. And then I'm going to bring this equation with me. Let's go down the page to where we left off. Okay, so there's my green equation. So I am going to replace this y with negative 1. I use parentheses, so I remember that I am multiplying. Otherwise, I might get confused and think, oh, it says minus 1. And that's not subtracting. That's multiplication. So I need to multiply the 3 times the negative 1. So here we go, 2x. This will be minus 3 equals 5. Okay, solving for x. In order to do that, I'm going to do plus 3 on both sides. These will cancel. 2x comes down. 5 plus 3 is 8. divide by 2. Divide by 2. Cancels. Shoop. X equals 4. So now I got my solution. I got both parts of the solution. My x coordinate is 4. My y coordinate was -1. I had that from earlier. The solution is going to go right here. So the x coordinate always goes first. 4 goes here. The y coordinate was -1. That's always going to go into that second spot. And I'm going to circle that right there. Let's do another example here. So I got, again, a green equation, a blue equation. All of the parts line up. I got x's and y's, equal sign numbers. That's great. Coefficients, are they the same? No, they are not. So whether I go with x or y, in neither of those cases are the variables the same. So let's choose one. Let's see, maybe we can figure out one will be easier than the other. Let's look. So if we're going to do x's, least common multiple for 5 and 10, I could go with 10. So the blue equation I won't need to change. The green one will need to be multiplied. And if I were to use the y, if I want to eliminate y, those coefficients, least common multiple for 1 and -7, I can go with 7. Or -7, I guess you could call it. So the blue equation, again, I could leave that one alone. It's already -7, that's fine, but I would need to multiply the green equation. So in either case, I'm multiplying one of the equations and leaving the other alone. So possible advantage for working with the x's, the least common multiple is 10. So I would need to multiply that top equation by -2 in order to get the green equation to have -10 as my coefficient, so that -10 in green and +10x in blue would eliminate. Okay, so multiplying by -2. If, on the other hand, if I work with the y coefficients, I'm going to multiply that green equation by 7, so that I end up with, in the green equation, +7y, and in the blue equation, I already have -7y, so those y's will eliminate. So I think you're fine either way. Doesn't really seem like a big difference in difficulty. Go ahead and work with the y's this time, just for the simple reason that basically I did x's last time, so we're going to try something different this time. So let's take this top equation. I'm going to multiply by +7. So I want the green y coordinate to be +7y, so that it will eliminate with that -7y from the blue equation. So I'm going to rewrite. 7 times 5 is 35. X plus 7y equals 63. And I go ahead and rewrite that blue equation just so that they're both in the same place. So I got 10x minus 7y equals -18. Now that we've chosen to work with the y coefficients, possibly if we'd chosen to go with the x coefficients, we'd have smaller numbers because we'd be multiplying by 2 rather than 7. That might make it easier to work with, but now we're already committed. So am I adding or subtracting this time? I want those y coefficients to cancel. I got +7y in green. I got -7y in blue. So we're going to add to get elimination. +7y, -7y, those are going to eliminate. So just go ahead and write that down now. And then let's go down the other column. So 35x plus 10x gives me 45x. That's a big number. The y's are eliminating one another. Let's bring down that equal sign. And 63 minus 18 is 45. Well, this isn't so bad then, huh? All right, so to solve for x, I got that purple equation, 45x equals 45. I'm going to divide both sides by 45 to get x by itself. And that will give me x equals 1. So half of the solution, again, we've done the majority of the work here, but it's only half the solution. So don't quit now. We're going to find y. So we're going to take that x equals 1. We're going to use that and substitute into any of the original equations, the original green, the original blue, or our modified green equation. Either of them will work. It looks to me like that original green equation's got the smallest numbers, so maybe we'll work with that one. Just gonna write it down up here where I can actually see it, and then we'll go ahead and move this down to the blank part of our workspace. All right, so I'm going to substitute 1 in the place of that x right there. So multiplying by 1. So first of all, we're going to multiply 5 times 1, so that is 5. So I get 5 plus y equals 9. And then in order to solve for y, I'll need to subtract 5 from both sides of the equal sign. So these cancel. Y equals, and 9 minus 5 is 4. So I've got the x is 1, the y is 4. Let's get that written down as a solution. X always goes first, so that's 1, and then y always is second, and that is 4. Circle our answer this time with some beautiful flowers for spring. Okay, last example here. The green equation, 3x plus 6y equals 6. Blue equation, 5x plus 4y equals negative 14. Do all the parts line up? Yes, x's, y's, equal sign numbers. That's great. Do any of the coefficients match? No. I got 3 and 5 for the x's. I got 6 and 4 for the y's. Neither of them match. Let's see what we would get for some least common multiples. If I was to use the x coefficients, least common multiple for 3 and 5, that's going to be 15. I will have to multiply both equations to make them into 15x. I have to multiply the top equation by 5, the bottom equation, the green one, by negative 3. If I was to work with the y coefficients, the least common multiple for 4 and 6, that's 12. So again, I'm going to have to multiply both equations, but I get slightly smaller numbers if I go with the y coefficients. 6 times 2 will give me 12, and for the blue one, I would use negative 3. Negative 3 times 4 is going to give me that negative 12. So I have opposite signs on those coefficients. So I would rather work with a slightly smaller number, multiplying by 2 and negative 3. So we're going to go with the y coefficients. You could totally do either one. Nothing wrong with working with the x coefficients. So we're going to multiply the top equation by 2 so that y coefficient will turn into positive 12. Let's go ahead and write that down first. So the green equation is going to be 6x plus 12y equals 12. Don't forget to multiply that constant after the equal sign. Sometimes people get so carried away, like, I am finished, and then they forget to change that last number, and you're like, why doesn't it work out? All right, the green equation is done. Let's move on to blue. The blue equation, so I would like to get that y coefficient to be negative 12 this time, so that I have opposite values rather than exactly the same. And so I got 4y in the blue equation. To get that to turn into negative 12, I'm going to multiply by negative 3 this time. So let's go ahead and multiply that whole blue equation. Everything gets multiplied by negative 3. So negative 3 times 5, that's negative 15x. Negative 3 times 4y, that's negative 12y equals negative 3 times negative 14. That is positive 42. All right, so got coefficients matching now. Positive 12y in green, negative 12y in blue. So I am ready to add these equations together. Since the coefficients are opposite signs, I just add, and so they will eliminate. So my y coefficients are going to eliminate. I know that already, so I set it up that way. Let's look at the x column. Positive 6x minus 15x is going to give me negative 9x. Positive 12y, negative 12y, eliminate. The equal sign is going to come down here. 12 plus 42, that is 54. So my new equation does not have a y in it. I eliminated the y's, just negative 9x equals 54. I can solve that for x. I'll need to divide both sides by negative 9. Oops. So negative 9x divided by negative 9 will give me just 1x. And 54 divided by negative 9 is negative 6. So there's half of the solution. Let's take that negative 6 and substitute it back into one of these original equations. So I've got more choices this time. I could use my modified blue equation, my modified green equation, the original blue, or the original green equation. Any of those four will work. You get the same answer. But I think using that original green one is going to be easiest since it does have the smallest numbers to work with. So I'm going to go ahead and write that down here where I can actually see what I'm talking about. 3x plus 6y equals 6. It's not really written very well, but I'm about to erase that x anyway. So let's carry that down here. Okay, so I'm going to substitute negative 6 into the x spot. We'll get rid of that. It was a badly written x anyway. Multiplying by negative 6. Okay, so we're going to do that multiplication as our first step. 3 times negative 6 is negative 18. Plus 6y equals 6. Okay, to solve this for y, next step will be to add 18. Easy eliminate. 6y equals 24. And grab a little bit more space. Next, divide both sides by 6. 6y divided by 6 is 1y. I'll just write down y. And 24 divided by 6, that's 4. So, a solution. X goes first. And that was negative 6. Y goes second. That is 4. And there's our solution.